point out something to all of you guys in the documentation. It's kind of a new concept that we haven't gotten to yet. So as you're working through these flags, you'll come to this one that asks if it's strand specific. So again, this is unique to an RNA-seq library because RNA is transcribed from a particular strand. So these library prep kits, they have methods of dealing with it so that you preserve the stranded information in the library and you know which strand the RNA molecule came from. So this is something that, depending on which kit you use, you can have a different thing. So they ask you what it is. If you didn't use a kit that preserves stranded information, it's going to be unstranded. Or you can also have something be stranded or reversely stranded. So the way that you have to figure this out is you have to look at the protocol for the particular kit that was used and see how they handle stranded information. So I've pulled up the TrueSeq protocol, which is what we saw on the ENCODE website. This is the mRNA-seq stranded information. And there's a step in the protocol where they talk about how they are synthesizing their cDNA, which preserves the strandedness of the library. So when you first have your RNA molecules and you do the reverse transcription, you're making an RNA-DNA hybrid. So you're going to have one strand of DNA. That's called your first strand synthesis. And then you're going to degrade away your RNA, and then you're going to use that template to prime and make your second strand synthesis. So the way that they preserve the stranded information is in the second strand synthesis, they replace a DTTP with a DUTP. So typically you don't have U's in your DNA, but in the second strand RT mix, they're using a DUTP. And so this will prevent further amplification of the second strand during your PCR amplification of your library, and it's going to allow for selective amplification of the first strand that you've reverse transcribed from your RNA template. And so what that means is that your library is now reversely stranded because you're only amplifying the copy that came directly from your RNA molecule. So you're only amplifying the reverse complement of your RNA. So in our instance, the library is reversely stranded. This is probably the most commonly used library prep kit, so the Illumina mRNA-seq TrueSeq kit. But again, if your library is made with a different kit, you need to pay attention to this and how stranded information is used. So for this, yes, our library is stranded and it's reversely stranded. And then the other argument that you're going to have to use with this is since we have paired end data, is the paired end orientation. So we need to specify the orientation of the two reads in the same pair. And the values that they're allowing you are FR, FF, or RF. So forward and reverse, reverse and forward. So since our library is reversely stranded, the first read that goes in the forward direction is reversed, and the second read that goes in the reverse direction is actually the forward. Does that make sense, or is that too confusing of an explanation? So if we're on the reverse strand, and when our first read goes in the forward direction, so our first read is forward, but our library is reversely stranded. So the first read in the forward direction is actually the reverse strand. And then our second read that goes in the reverse direction is now the forward strand. So we're going to use the RF. Yep.
How do you know which is which in the files that we don't know?
Because our files are specified with the information as which read was read 1 and which read was read 2. Remember in the SAM tools flags that we saw, it preserves the information of if it was the first or the second read in the pair. So that all of that information is stored in the BAM file. Does that make sense? Cool. Okay. Raise your hand if you've gotten through most of the flags and have thought about whether or not you want to use them. Gotten through most of them? Okay. Okay, so let's start working through these together. So the top argument is going to tell you you're going to have to give it input files. Are we going to give it input files? Yes, okay. Dash A, raise your hand if you think we need to include this. Great. And what argument are we going to pass into this flag? The GTF file. And we're going to give it the full path, yeah? Dash capital A, are we going to include this? Yes, raise your hand if you think yes. Great. Are we going to require both ends mapped? Raise your hand if you think yes. 1, 2, 3. Very timidly. More. Okay. So this is a decision that you can make. Our data seem to be very good quality, so most of our reads have both ends mapping. So we're going to require that both of them mapped in order to quantify expression using that read information. If for whatever reason you have a very poor data set, but it's precious and you're just trying to salvage whatever you can out of it, maybe you don't care if both reads actually mapped, but even if you got something, you'll take it. So we're going to use the dash capital B option. So since we're going to use this, are we going to give it any argument with this flag, or are we only going to pass the flag? Just pass the flag, great. And what other flag are we going to have to use since we're using dash B? Dash P, great. So this is specified below. This option should be used together with dash P. So if you try to use this flag but don't include the dash P, you're going to get an error message. Okay. Dash C, are we going to count chimeric fragments? No. Yeah, so that's a good point. We looked at this in STAR and we didn't see any in our output because we didn't perform the alignment in a way that was meant to pick up these chimeric reads. If that was something that we were interested in, we could have gone into the advanced options in our STAR manual and figured out how to include the flags to be able to pick those up. But in our data set, we're not interested in this. Minimum fragment length, dash D. Is this something that's important for our data set? Raise your hand if you think no. Raise your hand if you think yes. Okay, why would you use this?
So we looked at the file, the length is like 200, I think. So in order to hold control, I said a little higher than 50.
Okay, so yeah, 50 is by default, but remember that, yeah, 50 is the minimum. So if you wanted to do a quality control on our data set, we could say that we only want minimum of 200, meaning we only want to count from fragments that had a complete mapping, or you could say 197 if you want to get above the average. Since our case, the vast majority of reads were of this complete length, we didn't have anything that seemed funny where we had this weird distribution of read lengths. So adding this as a flag won't add much to our final output. Like you mentioned, you could be more stringent with it, but I think for our purposes, the default is fine, anything above 50, because the majority of our reads anyway that mapped are of that full length. Okay, so again, as the minimum, you could specify maximum, and by default it's 600. We don't have anything that's even close to 600, so this doesn't really matter either. Dash F, what do you guys think about dash F? Can somebody raise their hand and tell me what you guys talk to each other about regarding dash F? Yeah.
So we were very confused about it, but if it's wanting to know how we're supposed to be looking at it at the end, things by the genes, we got just included that. Well, it's just the default.
Great. Anybody disagree? Okay, yeah, so as she mentioned, it's telling you that the gene level is by default. We go back to thinking about what the goal of using this program is. The goal of our work is to quantify expression on the gene level. So we're going to keep the default. We're happy with that. If instead we were curious about the specific level of inclusion of each exon across the gene, in that instance you might want to change this to something like an exon level, or if we're interested in another specific feature about a gene. But for our purposes, we're interested in the whole gene, so using the default is fine, meaning this flag does not need to be included. Okay. What about this flag? Raise your hand if you think we need to include this flag. I can't hear you.
RVC version.
Oh, RVC version. I'm not sure. So yeah, it's telling you if you're C version, then that's going to be by default. R version is SAF. I don't know. So if you're not sure, then you can always just make it specify. So if you do -F, that's telling you that it's a GTF annotation file. So it's not necessarily clear if the default's going to work for us. So to be safe, we should include the -F to specify that we're giving it a GTF annotation. So the way that this is described is if you use a -F, that's saying that it's GTF annotation file. So you don't need to give that as the argument. Do we need to use this? I'm seeing a bunch of head shakes. No. Great. Do we need to use this? Seeing a bunch of head shakes. Yes. Great. It's asking you to provide this. Do we have this? You guys have seen this before? Great. Huh? Right, it's the allchrome.fast. What is stored in a FASTA file? Okay,
You should just set that as
great. And how is that different from a FASTQ file?
well, Q kind of stays in quality, so it has an additional line that represents the quality of the information.
Great. So we've already downloaded this. It's already in our HG19 annotations, so we're going to use that. All right, what do you guys think about -J? Did any of you discuss this flag in your group? And if you did, raise your hand and share with everybody what you discussed. Nobody got to -J? Okay, that's fair. So it's another option. If you're curious about junctions, you can include -J. But you're right, for our purpose, we're asking the question on gene expression, so this is not something that we're going to conclude. If you were looking at splicing later on, this might be something that you would think about including. Okay, what about -M? Okay, good point. 90% of our reads uniquely map. That's nice. So if we don't include this, then we're still recovering the majority of our data set and we're getting really good quantification based on the amount of reads that we have. If we do include this, you have to keep in mind that you're double counting fragments. So beware of that. But yeah, I agree. For our purposes, we have a lot of uniquely aligned reads, so we're happy with that. And are only going to quantify expression based on something that we're very confident on, and those are the uniquely mapped reads. Are you going to use -O? Yeah? Okay. We're going to give it an output. Okay. So we already talked about the -P we're going to use for paired end. We talked about the strand specificity. You need to describe. -T, did you guys get to -T? What did you think about -T? Oh, -capital T. Yeah, you're good. How about -lowercase t? Did anybody talk about that one? So this one is a little bit confusing. I think ultimately, yeah, I decided not to include it because the default is going to be fine. We will tomorrow go through a more in-depth example of a GTF file, and this will make more sense to you guys then. So I'm going to skip over it now, other than to say we don't need to include this. Okay, and lots and tons of arguments, but for the sake of time, we've hit the main ones. that and understand it relatively well. Okay, cool. Okay, so feature counts, as I mentioned, it's included in this larger package called subread, and yay, it's available for installation with Conda. So we're gonna install it in the BioConda channel. It's available on BioConda. As I mentioned, it's buried inside of this package called subread. So if you didn't know this already, you would say, can I install feature counts in Conda, or BioConda? I get links about BioConda documentation. Sometimes this can take a little bit of searching and a little bit of trial and error. Okay, so I found in the documentation that I need to download the subread package in order to install all of these commands. So now I can look for how to install subread with BioConda. And I see that there's a documentation available for subread. And it's Conda install subread. And since this is specific to the BioConda channel, it's here on BioConda, that's why we need to include -C BioConda. So I have it on here for you guys, but I just wanted to go through that as an example because I keep saying check to see first if it's available to install with Anaconda. So that's kind of the rationale of how I got through that to find this. Raise your hand if it installed and which feature counts is available to you. Great. Keep in mind feature counts has a capital C here. It's kind of great. Okay. Brian, how are those files going? Are they done? Okay. So before we run this, we're going to run this on all of our BAMs. Let's try making our soft links again. The files should be up there. What, Brian?
Good, yeah. You change it? No. You change it?
So you need to change it on the ones that you made? Brian, are you changing the permissions on those files?
Yeah.
Okay. Great. So once he's updated those permissions, which they're there now. So again, it's these these are the files that we need. Each BAM has an index with it. I don't think for feature counts we need the index, but we might. So we're going to just copy all 8 of them. Did you intend to get rid of your X here? Okay. So you can't execute, but everyone else can. Raise your hand if you successfully made the soft links into your all BAMs directory. Working on it? Okay. Try samples view on one of them and pipe it into less. One shortcut to remember on the destination, if you're in the directory where you want them to land, you can just do / instead of the whole directory. Yeah, so that's how mine worked. And then right back. Oh, yours going where it's not. I need to check it. Just see the where it is replaced.
Oh.
It's not the original.
Oh.
You can see this supplement is present. Right here. Yeah, so this Oh, you didn't start to come to your generator? Yeah, I haven't used it yet. You don't need it. Yeah, I don't know. Raise your hand if you have successfully made all of these soft links. Good soft links? Not quite yet. Okay.
I just know, I mean, you see this, then you can't go into my second.
Okay, so clear your screen. Clear. So you type on C0. Okay, so LS. So what is Okay, so you want to remove
I was in the directory, but the whole directory.
Okay. Yeah, for some reason I'm not sure because I was trying to figure out where it was. It's also like a lot of stuff is around there. So you go up. Okay, so maybe the one we need is a stop again, because that's the directory. It said it already existed, so it would make it. So as we deleted it, that should be okay. But I'm actually trying to make it you can try to get it slash at the end. You can go to the directory. If that doesn't work, just to your directory, just follow this instead of the dot slash to say but so the other thing that's And also, I think the other thing that this all the names that you're going to is really good. So you can just
No, but I want your software to be called all the others.
no, you're going to see how it is in my computer. Your software is in the directory, but you want each one to be individually. So you're going to create a software for each of your product. So the other thing is this is just like a slash at the end, so that's actually the directory where it's going. You're stopping all of these is certainly located in each of them in the directory.
So I can do this, so I can do Ellen, and I can do basics to all of this if I change that.
But it adds slash to all of it.
It has to be fine.
go into your all BAMs directory, so you'll call that with slash, and then this is the software. Okay. Raise your hand if you have successfully made the soft links. Okay. In all BAMs. Yeah. So it's just a way to keep things organized. So if you were to put the soft link in your home directory and then you're trying to run programs on the BAMs for your Lin 28 project, it's going to be confusing to know where those BAMs were. So that's why we're burying them in this directory that we've called Lin 28 all BAMs. Okay. All right. So we're getting close to the end. So I'm going to point out a few things with feature counts. Feature counts isn't too memory intensive, and again, this is stuff that I've learned just by trying the program and doing it, so you guys are welcome to try a couple different things on your own, however you would like to do it. You can write a .sh script, which is what I've put here on the instructions, but I can also give you guys a shortcut for how to do it. So for feature counts, remember one of the arguments was an input file. It required an input BAM. I know this based on having done the program, and you guys can try it yourself. If you give it a wildcard character, it will work on multiple BAMs at the same time, and it will very nicely put your output. So it mentioned it's a tab-separated file. It will give you a new column with the counts for each of your files, all in one, instead of having a tab-separated output for each of your outputs. And you'll see that when you run it. This is the command that we talked about, all of the different flags that we were going to use. And then when you specify in the output, ignore this directory because it's not right. Put it somewhere that you have it, you know it, where it exists in your Lin 28 folder. You can give it, you can either put it in your all BAMs, you can put it somewhere in, you can make a new directory called feature counts in your Lin 28 project. So the way this is going to work, when I specify -O, I'm giving it the output name Lin 28 shrna all feature counts because I'm doing it with the star BAM. I'm doing it on all of the BAM files at once. I'm doing this on star BAM, but this is only going to work if I run this in the directory where my BAMs are. But you guys should also know, this is something that's small enough that you can run it on the head node without submitting a processing script. So on your head node, you can use the command that you've built. You can specify an output, and again, don't use this. Use something that makes sense to you. You can either put it in your star output if you want, or you can make a new folder called feature counts. And then you can either run it in the directory where all of the BAMs exist, so run it in that all BAMs directory, or make sure you give the full path in addition to this star wildcard character. Okay, does that make sense to everybody? Cool. So hopefully by tomorrow, you guys can have run this command and take a look at the outputs that you get. You're going to get a summary output, and you're going to get a tab-separated file output. So what I want you guys to come back with tomorrow is, and if you guys that are using desktops, again, if you don't have time to run this command, you can send it to me and I can run the command for you and send you your output. But after you run it, and you can read about this more in the documentation, it's going to tell you the reads that were assigned. So what I want is for each data set, come back with the percent assigned reads of total. And you can find this in your output files. This is kind of like another summary statistic about how well our counting went and how well the reads that we have mapped are actually being called and aligned to these features. Joanna, did you have a question?
Yeah. So the very first box on that table we're looking at says input files.
Yeah.
Are those up there?
So this is my input file. I have it at the end. It might also work if you have it at the beginning. Sometimes programs are more sensitive to it than others. Again, that's something that you can just try if you're getting error messages because it can't find your input files You can change the order of it around. Sometimes it matters, sometimes it doesn't. But yeah, the input files, remember, we're counting features from our BAMs that we've made. So our BAM files are the input, and that's specified here. And I'm using the star wildcard character because I want to do the counting on all 4 of the BAMs at once. So all of the conditions, we're going to count them at the same time. If I were to count it individually, instead of this being star.bam, it would be lin28.1 knockdown rep1 dot sorted dot bam. And then I would have another command that says lin28 knockdown rep2 dot sorted dot bam. There's still some confused spaces, yeah?
So do we not have to specify where the band files are?
You do.
So we have that.
Yep. Yep.
Where do you have like before those starting?
Where would I add what? The location is always associated with your file. So this command would run, but only under one condition. What condition is that? Okay. If you're not in that folder, you give it the full path of your file.
But you can give the cat slash
Yeah.
star.
You can put this, so the star wildcard character works at any orientation. You can put it in the middle of something, you can put it at the end, you can put it at the beginning, you can use multiple stars. So yeah, you can put the star in the middle. Yep.
So since that band is not unique to just the band files we have, and it's also in the .band files, is that kind of that sort of thing? So we have the same folder, is that okay?
So the star wildcard character, because we only have it at the beginning, we're telling it, I don't care what happens before, as long as it ends with .bam. So is this also going to pick up the .bam.bai? No, because .bam.bai is different than .bam. If I were to put another star over here, then we would have a problem, because it would also be picking up the .bai. But since I don't have a star at the end, I'm requiring that the end of the file is unique for this .bam, and I don't care what comes before it. Yeah.
Does the ordering of the tabs matter?
Of the dash flags?
Yeah.
No. That generally never matters. Some programs will be more finicky than others about if you put your input file at the very end or at the very beginning. So Joanna pointed out in the feature counts documentation, it's the first thing listed, so you might be able to put it at the beginning. But also looking at those example commands from that first Google page that we went to, you can kind of follow the syntax that they've used. So if theirs are all at the end, maybe put yours at the end as well. But if theirs are listed at the beginning, then that probably means that the beginning will work too. Again, if it messes up and you get an error message, it's really not a big deal. You just rerun it. So some of you guys were not able to finish your star mapping yet. I put the aligned SAM file back in here. Oh, well, it's not there anymore. Back in that MSTP folder. I have not yet put the star generate index in there. So if your star index generate has not yet finished and you're relying on that folder, hang tight. I'll put it there after class. But if your star index generate has worked, use that for your mapping job. Use the location of your specific folder, and you should be able to get the mapping for your SAM file. Any more questions? Okay, great. So try to run this feature counts on your own, and come back tomorrow with a report of the percent of reads that were uniquely assigned for each of the 4 data sets that you're running. And those of you that are on the desktop computers, if you haven't been able to submit the command yet, again, this lab is open until 7 p.m. and it opens at 7 a.m. tomorrow, so if you have time to come back, go for it. If not, you can send me the command. Send me literally exactly what you want me to run, and I will just run it. So if there's any error messages that are associated with it, then you'll get that back. And once it's run, I can send you the output files. I'll just copy them off of the TSCC and put them in an email to you so that you can look at outside of TSCC. Okay, thanks guys, see you tomorrow.